Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. So today we are going to continue with the most important MCQs part 2 of General Principles and Process of Isolation of Metals. I have already uploaded the first part of MCQ. Also the lesson in 2 parts also has been already uploaded. So those who haven't watched can go back to the session and continue watching. Okay, so before we start with the first question for today, I would like to explain how to strategize revision in the last few months of NEET preparation. So firstly, you have to divide the topics within the overall preparation or revision time. Start with dividing the important topics with an approximation breakdown by time. It can be in weeks or months. So for physical chemistry, make a condensed formula sheet and solve previous year NEET question papers like AIPMT before 2013 as well as NCERT problems. NCERT exemplar is another great source of questions. And regarding to inorganic chemistry, NCERT is by far the best book for inorganic chemistry. This is also the highest reward versus effort section. Also in organic chemistry, general organic chemistry and named reactions should be revised thoroughly. NCERT should be referred for this session as well. Okay, now we will start with the first question for today. Okay, what is the first question? It's what is the role of rotating paddle in flotation? So if you remember, we have already learned in detail about flotation, magnetic separation, all these processes. We learned like concentration of elements and everything in metallurgy, different process we have learned already and have already uploaded all these things in my previous sessions. Okay, so what is the role of rotating paddle in flotation? We have got the 4 choices. A is enhances wettability of gangue particles, B stabilizes the froth, C draws in air causing frothing, D enhances non-wettability of the ore particles. So what is the correct option? It's option C, draws in air causing frothing. So in flotation process, already as we have studied, the suspension of the powdered ore in water along with the collectors and froth stabilizers is violently agitated by the rotation of the paddle, which in turn draw air causing frothing. So option C is the correct answer. Okay, now coming on to the next question. What is the type of metallurgy in which the ore is leached and the metal is collected by using electrolysis? A is its own refining, B hydrometallurgy, C liquefaction, and D thermite process. Okay, the correct option is B hydrometallurgy. Okay, what is hydrometallurgy? It's a technique within the field of extractive metallurgy for doing what? Obtaining metals from their ores. Now this process involves the use of aqueous solutions for the metal recovery from ores and concentrates and recycled or residual materials. Okay, now B is the correct option. Okay, what is the next question? When is the ore subjected to leach? 4 options are A, when the ore is in immiscible liquid, B, when the impurity is in immiscible liquid, C, when both ore and impurity are insoluble in water, D, when only impurity is soluble in water. So the correct option is C, when both ore and impurity are insoluble in water. So when the ore is subjected to leaching, both the ore and impurity are insoluble in water. So leaching process is commonly referred to as extraction. And what is this process? It is in which water soluble substances are washed out from the soil or waste. Okay, now next question. Which of the following statements is wrong? Wrong. Okay, just notice it. Most of the students never notice what is given properly in the question. Okay, so 3 are right and 1 choice is wrong. So A, during smelting, flux is used to remove gangue as slag. Then B, the slag formed during the smelting has low melting point and it's heavier than the metal. And C, calcination of ore is carried out without the presence of oxygen. D, roasting is carried out in the presence of oxygen. Okay, so what is the correct choice? It is option B, the slag formed during smelting has low melting point and is heavier than metal. Okay, so what is smelting? It is a process of extraction of a metal from its oxide by reducing it with carbon or coke. So actually alkali metals, alkaline earth metals, these all cannot be prepared by reducing their respective oxides with carbon. So the slag formed during smelting has high melting point and it's lighter than the metal. So option B is the correct choice. Next one, Roasting results in the formation of oxides, but why are oxide ores, why are they subjected to roasting? So why? To avoid gang particles, to get crude metal with using oxidizing agent, to remove volatile impurities in the form of their oxides, and to make the ore porous. So what is the correct option? It is C, that is to remove volatile impurities in the form of their oxides. So oxide ores are subjected to roasting to remove the volatile impurities which are present in the form of their oxides. So it's easier to obtain metals from their oxides. We have already seen it by reduction than from carbonates or sulfates. So before reduction can be done, ore should be converted into the metal oxide. Okay, now coming on to the next question. Which of the following ores are concentrated by flotation? Is it hematite, zinc, copper pyrites, or magnetite? Option C, that is copper pyrites, is concentrated by flotation. So what is flotation method? It's widely used for concentration of sulfide ores like zinc blende, copper pyrites. Just remember the formulas written here, galena, PBS. So this method is based upon what fact? That the surface of the sulfide ores is wetted preferentially by oils, while that of the gangue is preferentially wetted by water. So one is by oil, that is the sulfide ore surface is wetted by oil, gangue is wetted by water. Remember that point. Okay, now what is our next question? What is the main reaction occurring in the blast furnace during extraction of iron from hematite? Okay, we are having 4 reactions given here. Okay, Fe2O3 plus 3CO gives 2Fe plus 3CO2, FeO plus SiO2 gives FeSiO2, Fe2O3 plus 3C gives 2Fe plus 3CO, Fe2O3 plus CO2 gives FeCO3 plus oxygen. Okay, A is the correct choice. This Fe2O3 plus 3CO gives 2Fe plus 3CO2. So what is happening in this reaction in the blast furnace during extraction of iron from hematite? That is, the reaction involves the reduction of iron 3 oxide to iron and oxidation of carbon monoxide to carbon dioxide. I hope you understood this explanation well. Okay, now how is ore dressing of iron done? Is it by flotation, magnetic separation, hand picking, or by wetting? So the correct option is option B, magnetic separation. So in magnetic separators, as we learnt already in our previous session, the effect of magnetism is used to separate ferromagnetic materials from non-magnetic materials. So in principle, this process is most suitable for the iron ores because they are magnetic in nature, siderite and hematite, which become weakly magnetic when heated. Okay, so option B is the correct choice. Now next question, which of the following metals is not extracted by electrolysis? Which method, for the extraction of which metal we don't use electrolysis process? Is it sodium, magnesium, aluminum, or iron? So the correct answer is option D, iron. Actually, the extraction of a metal from its ore, it mainly depends upon the selection of proper reducing agent. We learned it already. So iron is moderately active and the oxides of iron can be reduced using carbon and not by electrolysis. So reactive metals like aluminum and all are extracted by electrolysis, while least reactive metals like iron is extracted by reduction with carbon. Hope you understood this. Now next one, which is the correct Gibbs equation? Delta G is delta H plus T delta S, delta G is equal to delta H minus T delta S, delta G is equal to delta H minus 2T delta S, and delta G is equal to delta H minus 3T delta S. Correct option is B. What is B? Delta G is equal to delta H minus T delta S. Okay, for any process, the change in Gibbs free energy is given by the equation delta G is equal to delta H minus T delta S. So where delta H is the enthalpy change, delta S is the entropy change, and T is the absolute temperature. Okay. Now moving on to the next question. What is the criterion of the feasibility of reaction at any temperature? Delta G of the reaction is positive, delta G is negative, delta G must be 0, or it does not depend on the delta G of the reaction. So the option B is the correct one. What is it? Option B, delta G of the reaction must be negative. So here the criterion for that is the delta G of the reaction must be negative. And the feasibility of a reaction at any temperature, for a reaction to be spontaneous, the value of the change in Gibbs energy or delta G of the reaction must be always negative. Remember that. Option B is the correct choice. Okay, how can a reaction with positive delta G be made to occur? Is it by increasing the temperature, by decreasing the temperature, by coupling it with another reaction, or is it not possible for the reaction to occur? Which is the correct choice? Option C. What is it? By coupling it with another reaction. Okay, so what happens is that a reaction with delta G positive is made to happen by coupling it with another reaction having large negative delta G. So net delta G of the two reactions will be negative. That is, delta G is equal to change in Gibbs energy of the reaction. Okay, what is the next question? This is very important, Ellingham diagram. So many questions normally come from that. So is it plotting of delta Fg0 versus T, or T versus delta Fg0, or plots of delta Fg0 versus delta S versus delta Fg0. Which is the correct option? Is A. A is the correct option. So here this Ellingham diagram, normally it consists of plots of delta Fg0 versus T for the formation of element oxides, and similar diagrams also can be constructed for sulfides and halides of elements. So what is the uses of these diagrams? They help in predicting the feasibility, that is whether a thermal reduction of an ore will occur or it can happen or not. Okay, now under what condition can aluminum reduce MgO? Above, is it 1000 degrees Celsius, below 1000, above 1350, or below 1350? What is the correct option? C, that is above 1350 degrees Celsius. So the explanation is, that is for a reaction to happen, or if it should be feasible, the change in the Gibbs free energy, or delta G, must be negative only, then the reaction would become feasible. So what happens if delta G becomes lesser? The feasibility will be greater. That is above 1350, the Gibbs free energy of formation of Al2O3 from aluminum is less than that of MgO from magnesium. So therefore aluminum can reduce MgO above 1350 degrees Celsius. I hope you understood the explanation here. Okay. Now which of the following is false regarding the Ellingham diagram? It consists of plots of delta Fg0 versus T, and it's based on the thermodynamic concepts. They do not tell us anything about the kinetics of the reduction process, or they do not assume reactant product equilibrium. So what is the correct option? It is D. They do not assume reactant product equilibrium. So interpretation of delta G0 is based upon K, that is we have already learned this, delta G0 minus RT ln K, that is it's assumed that the reactants and products are in equilibrium, but always it's not true, because the reactant or product may be solid. Okay, so option D is the correct answer. Now which of the following statement is true? Aluminum can reduce zinc oxide more readily than magnesium. Zinc can reduce Cu2O, cuprous oxide, more readily than aluminum. Mg can reduce ZnO more readily than aluminum. Zinc can reduce U2O more readily than magnesium. So answer C, that is magnesium can reduce zinc oxide more readily than aluminum. So the tendency of these metals to act as reducing agents, just remember this order, that is it's given in the, magnesium is largest, next comes aluminum, then zinc, iron and copper. So magnesium can reduce aluminum oxide, zinc oxide, iron oxide, cuprous oxide more readily than aluminum can reduce ZnO, FeO and Cu2O. Similarly, aluminum can reduce ZnO, FeO and Cu2O more readily than zinc reduces FeO and Cu2O. This is very important. Remember this order as well as the condition for reduction. Okay, now next, which of the following metals are reduced from molten salt solutions by electrolysis? Is it aluminum, silver, iron or zinc? Option A, aluminum is the correct one. So highly electropositive metals are reduced to metals, metal oxides are reduced to metals from molten salt solutions by electrolysis. So aluminum is a highly electropositive metal. It's separated from bauxite by the process known as Hall-Heroult process. Already we have learned this. Okay, now what is the process used to extract sodium from halide ores like sodium chloride? Is it pyrometallurgy, hydrometallurgy, electrometallurgy or magnetic separation? Option C, what is it? Electrometallurgy. That is a process used to extract sodium from halide ores like sodium chloride, because sodium is highly electropositive metal and it is easily extracted from sodium chloride, for which we use a process known as electrometallurgy or electrolysis. Pyrometallurgy and hydrometallurgy, they are normally used to extract metals like copper, iron, silver, etc. Okay. Now next question, what is the term given to the extraction of aluminum from bauxite by using electrochemical process? Is it Bayer's process, Hall-Heroult process, MacArthur process or blast process? Option B, what is it? Hall-Heroult process. So here we already learned that it's melting process to reduce bauxite to aluminum, pure aluminum. So bauxite is first dissolved in molten electrolyte composed of sodium, fluorine, aluminum, and it's maintained at high temperature. So here aluminum is accumulated at the cathode and oxygen at the anode. Okay, what is the anode and cathode used in Hall-Heroult process? Is it zinc and copper, iron and copper, carbon and zinc, or graphite and carbon? The correct option is graphite and carbon, because in the extraction of aluminum from bauxite, anode and cathode must be inert, because like graphite and carbon, so that they do not take part in the reaction. So at the end of the process, metal will be accumulated at the cathode or it's collected from the cathode, and easier to collect aluminium from carbon electrode as it does not react with aluminium. Okay, so option D. Now with that we come to an end of this session as well. I hope you have all enjoyed learning the MCQs as well as I enjoyed in teaching you. And don't forget to share, subscribe and like my channel. Do subscribe to the channel and share it with your friends, and don't forget to press the bell icon so that as soon as I post my videos you'll get the notifications immediately. So with that we'll be coming to a conclusion. So I'll be uploading the next few lessons quickly, because as you all know, NEET 2022 is approaching fast and we've got only a couple of months to complete all the chapters and do the revisions. So I hope you're all preparing well for the exams. So with that I'm closing the session for today. Thanks for watching.